On this podcast, we're going to be balancing chemical equations. We're going to just quickly kind of go over law of conservation of mass and then do a lot of examples. So the whole basic idea behind balancing equation is that mass is conserved in a chemical equation. What that means is the mass before a chemical equation equals the mass afterwards. So mass is neither created nor destroyed during a chemical reaction, but it is conserved. Chemical equations not only show reactants and products, but it must also show that mass is conserved. So what that really means in a nutshell is that the number of elements in the reactants always equals the number of elements in the products. And we will use something called coefficients to balance it out. So let's do a very easy example. So here I have hydrogen gas reacts with chlorine gas to form hydrogen chloride. Now, this is written correctly from the word problem, so don't forget your diatomics. Now, what I'm going to do is I'm going to make a list. So, for example, on the left side, I have the elements hydrogen and chlorine. And again, I'm sorry for the penmanship. I'm running with my opposite hand. And I have hydrogen and chlorine in the product side. I am now going to make a list of how many elements I have on each side. So on the left side I have 2, that's from this, and then from chlorine I also have 2, so I have 2 elements of chlorine, 2 elements of hydrogen. On the right side I only have 1 hydrogen and I only have 1 chlorine. So in this example, the number of atoms of each element is not conserved. I have 2 elements of hydrogen on the left side and 1 element of hydrogen on the right. So this is not a balanced equation. So the way we balance it is that we will write coefficients in front of the compounds to help balance. So on this side, for example, I have 2 hydrogens. I'm going to need 2 hydrogens on the right side. So I will write, change the color here, I will write a 2 over here to help balance. This is my coefficient. They always go in front of either the elements of the compounds, whatever you have. So in this case, I'm putting in front of the HCl. Now I got to do some math. So now I have 2 hydrogens. So that's no longer 1. That is now 2. And I also have now 2 chlorines. So I'm going to write 2 here because of this 2 that I put there. So now I have 2 hydrogens on the left, 2 hydrogens on the right, 2 chlorines on the left, 2 chlorines on the right. That is now a balanced chemical equation. This is the correct answer. If you notice, I will never touch these subscripts on these ever during a balanced chemical equation. I can only put numbers in the front of each one to help balance. Before I move on to some examples, here just some steps to help you balance chemical equations. So make sure you write the chemical equation, write the skeleton equation for the reaction. This is very, very important. If you don't write the skeleton equation correctly, you will have a very, very hard time balancing. Make sure each compound is balanced correctly. That's very important. Never touch the subscripts after each compound is balanced. Count the atoms of the elements in the reactants, which I showed in the previous example on the left. Count the atoms of the elements in the product side, which I showed on the right. Change the coefficients to make the number of atoms of each element equal on both sides of the equation. And when we write the coefficient in the lowest possible ratio, and we check our work. So the rest of the slides here are going to be examples, and a lot of them I picked for a reason. So let's do another practice here. So nitrogen gas, N2G, so that's written correctly, reacts with hydrogen gas, good, that's written correctly, to produce ammonia, and ammonia again is NH3. So it's important that I make sure that each one is balanced correctly. If you forgot that nitrogen is the diatomic, you would have written N, and then the mistakes would cascade from there. So it's important to double check that each one is correct before you even move on. Alright, the next part is I'm going to make my little laundry list of elements. So on the left side I know I have nitrogen and I have hydrogen. On the right side I know I have nitrogen and I have hydrogen. So there's my list of elements on both sides. They always have to be the same on both sides. On this side I have two nitrogens and I have two hydrogens. On the right side I have one nitrogen and I have three hydrogens from the three there. So this is definitely not a balanced chemical equation. The elements are not balanced on both sides. So what can we possibly do to balance? Well, let me change my color here. So I have two nitrogens here. I'm going to put a 2 in the front. And now I got to recalculate. So now, these will now erase. I now have two nitrogens here. But now this is like math, distributive property. 2 times 3 is going to be 6 hydrogens. So now I have 6 hydrogens on the right and 2 nitrogens on the right because I put that 2 in the front. It affects everything that's in that compound for this. So my nitrogens are balanced but not my hydrogens. So I'm going to put, I need 6 hydrogens on the right, I'm going to need 6 on the left. So I'm going to put a 3 here because 3 times 2 is 6 and that would balance that out. So I'm going to put a 3 there. Oops, not a 3. I'm going to put a 6 there. There we go. That is now a balanced chemical equation. 2 nitrogens, 6 hydrogens on both sides. This is now balanced. Let's go on to another example. Oops. Okay, here I have barium chlorate. Breaks down into barium chloride and oxygen. So again, I'm going to make my laundry list of elements. Ba, Cl, and O. Those are my 3 elements on the left. I should have those exact same on the right every single time. Cl and O. Okay, on the left side I have 1 barium. Now, this 2 here distributes. So this 2 distributes to every element. So on this one I have 1 chlorine times 2. That's going to make it 2 chlorines. 2 times 3 is going to make that 6 oxygens. So that 2 does distribute to each element in the parentheses. On the right side, on the product side, I have 1 barium, I have 2 chlorines, and I have 2 oxygens. So this is definitely not a balanced chemical equation. I have to balance. Well, my bariums are balanced. My chlorines are actually balanced. It's just my oxygens are not. So to balance, I have 6 oxygens on the left. I only have 2 on the right. To get 6, I'm going to put a 3 right there. And guess what? This was actually a really easy one. This is going to make that a 6. 3 times 2 is 6. And now is now a balanced chemical equation. So that is my final answer. Pretty easy. Another example. Okay, I have aluminum, hydrogen, and chlorine. So I'm going to make my list. Now for the sake, I'm letting you know that each one is already balanced. I just want to get into the idea of how to balance this. I have hydrogen and I have chlorine. On the right side it has to be the same. Aluminum, hydrogen, and chlorine. Okay, here I have 1 aluminum, 1 hydrogen, and 1 chlorine. On the right I have 1 aluminum, 2 hydrogens, and 3 chlorine. So this is definitely not balanced. Alright, so what can we do to balance it? I have 2 hydrogens here. Let's try playing around with some numbers here. I'm going to put a 2 here and see what happens. So now I have 2 hydrogens and 2 chlorines. Okay, my hydrogens are balanced, but my chlorines are not. And now we got this weird number here. How can I get chlorines to be balanced when there's a 2 there on the left and a 3 there on the right? So well, 2 and 3, the lowest common multiple is 6. So I'm actually going to erase this, and I'm going to put a 6 here instead. So that makes this 6 hydrogens and 6 chlorines. And on the right side, I have 3 chlorines here, so if I put a 2 here, that makes that 6 chlorines. And if you notice, my aluminum is now going to change. So now I have 6 chlorines, and now I got 2 aluminums. My hydrogens are still not balanced. I have 6 hydrogens on the left. I'm going to need 6 on the right. So I'm going to put a 3 there, because 3 times 2 is 6. Now my hydrogens are balanced, but I have one last element, and that's going to be aluminum. Now I'm going to have to put a 2 in the front of this aluminum to balance that aluminum. So now that is now a balanced chemical equation. They do get kind of tough sometimes, and you have to play with some of the numbers to try and get them right. So in this case, I just did a little trial and error, and I found out that these are the coefficients for this balanced chemical equation, and this equation is now balanced because all my elements are balanced. Okay, next slide. Another example. I'm going to get to this one. All right. Now, here's a little tip. If you see a polyatomic ion on both sides, you can actually keep them together. So I know from my polyatomic ion list, hydroxide. So instead of separating each element by themselves, I'm actually going to keep them together. So let me show you how I do that. So here I have iron as one element, chlorine, sodium, and since I know I see a polyatomic ion and it's on both sides, I'm actually going to keep an OH together as one. And what I do on one side, I have to do to the other side. Okay. On the left side, I'll just change color because the blue is getting boring. On the left side, I have one iron, 3 chlorines, 1 sodium, and I have 1 hydroxide. On the right side, I have 1 iron, 1 chlorine, 1 sodium, but then this 3 distributes to each hydroxide, so I have 3 hydroxides. So now that those are, I've now labeled them and found out how many I have to balance. So I'll just start out with hydroxide. Since I have 3 on the right, I'm going to put a 3 right here on the left. And now that I put that 3 there, it's going to recalculate my hydroxide and my sodiums. So I'm going to rewrite that. Now I have 3 sodiums and 3 hydroxides. Well, I need to have 3 chlorines on the right here because I have 3 chlorines on the left, so I'm going to put a 3 in the front here. And since I put a 3 that I have to recalculate. So I'm going to put a 3 right here in front of the sodiums and put a 3 right here in front of the chlorines, and voila. I have equal number of elements and polyatomic ions on both sides. That is now balanced. So this is my final answer after all was said and done. So we're done with some of our examples. I hope the ones that we went over helped you learn how to balance chemical equations.